Let's go over patterns and linear functions. So basically for a function, you think of it as some type of a machine where you put one thing into it and out comes something else. So x could be any number and then we got a y value associated with it. So we might end up with something like this. When x is 0, y is 3. When x is 2, y is 9. When x is 7, y is 28. Okay, I'm just giving you some example. Put in an x value and you'll get a y value. So how does this relate to linear functions though? Well, a linear function would be when we take these x and y's and we plot the points on the graph with x coordinates, y coordinates, they would form a straight line if we were to connect them. So there's something special about a linear function. This is an example of linear function. So when x is 0, y is 3. When x is 1, y is 5. When x is 2, y is 7. 3 gives us 9, and 4 gives us 11. Okay, what makes this linear, just by looking at this table, is that it increases at a constant rate. So when this increased by 1, this increased by 2. Again, this went up by 1, this increased by 2, and so on. So another example, we don't have to start at 0, we could start with 3 maybe. And this could be any number. But when we increase to get the next one, they'll have to increase at that same rate. So if we increase by 4, for example, we'll have 19, then 23, then 27, and 31. So this kept going up by 1, and this kept going up by 4. This is also a linear function. And if we look at this one, let's graph this. So 0, 1, 2, 3, 4, and here we'll count by 2's. 2, 4, 6, 8, 10, 12. Alright, so this is our x, and this will be our y. So 0 is 3, 1, 5, 2, 7, 3, 9, and 4, 11. And of course this is freehand, so it's not perfectly straight, but we could see that it would be a straight line. So if it goes up by a constant rate, then it's going to be a linear function. So how can we write a linear function? Well, let's look at another example. So let's say we keep on going up by 3. This one would be that y equals just 3 times whatever x is. So if we multiply this by 3, we get the y. 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is 12. Okay, let's look at another one. Let's count by 4's. 4, 8, 12. So here we see just multiply x by 4 and we'll get y. So these y values are just 4 times the associated x values. So if we put in 0 into here, we would get 0. If we put 1 in, this is y equals 4 times 1, so 4. If we try this one, y equals 4 times x, so 4 times 2, we would get 8. And the same thing would work up here. So y equals 3x, so if x is 2, we have 3 times 2. Now it would give us 6. If we have an x value of 4, that would be 3 times 4. And that, of course, would give us 12. Okay, but they don't always work out this way. Sometimes they're a little bit more complicated. So what happens if now we start counting by 3's? So this is no longer y equals 3x. Because 1 times 3 does not equal 5, and 2 times 3 does not equal 8. Instead, it's going to be still 3 times x because we're increasing by 3 each time. But we have to do something else to the function. So 1 times 3 is 3, not 5. But if we add 2 to it, we'll get 5. 2 times 3 is 6. Then plus 2 more would give us 8. 3 times 3, that would be 9, plus 2 is 11. So in this case, the function is y equals 3x plus 2. And then let's just try this point, see if it comes out. So let's put 4 in for x. So we have y equals 3 times 4, which is 12, plus 2, and that comes out to 14. So y equals 14.